All right, greetings everyone. Welcome to the second part of the video for section 6.5. Continuing on looking at some word problem examples or applications of the stuff we've been studying in chapter 6. All right, let's go back to Ferris wheels and look at this problem. So we're told that the London Eye is a Ferris wheel with a radius of 67.5 meters that stands on a platform 6.1 meters above the River Thames, and yes, that's pronounced the River Thames, not River Thames, and completes one revolution every 30 minutes. We want to know how long a rider is on the eye at a height above 100 meters. So a lot going on in this problem, right? Now, as you may have figured out from section 6.1, to model these types of problems, it could be helpful to draw a picture, which is what I'll do down here. Also, we need to write an equation here before we can start to tackle this problem here about how long someone's above a height of 100 meters, right? Okay, so what I'm going to do over here on the side is I'm going to draw my Ferris wheel as best I can. So it's going to look something like this. Here's the platform. Okay. And we know that the radius, we're told that the radius of the Ferris wheel is 67.5 meters. We also know that the height of the platform, this here, that's 6.1 meters. Okay. Which can give us some information now to put onto our graph. So we know that the lowest point that the Ferris wheel ever reaches is at 6.1 meters. And then the radius is 67.5 meters, which can use to find that the entire width or diameter of the Ferris wheel will be twice that, which is 135 meters. Which means our highest point our Ferris wheel reaches will be 6.1 meters plus that 135, which gives us 141.1, which is not what I meant to write there, 141.1 meters, right? The middle point here, okay, which will help us find our midline, well, that's going to be the distance from the platform to the center, which the center of the Ferris wheel, which will be a length of a radius, which is 67.5 meters. So we can now take 6.1 plus 67.5, so we get 73.6 is the location of our midline then. So we know this will go through the middle of the function. And then we're also the Ferris wheel completes one full revolution in 30 minutes. So we know that kind of tells us how long it takes to go all the way around, which then if we start at the top of the loading dock there, the platform, and you imagine as the Ferris wheel spins, we can max the height or model the height like this. So it'll go up to the top and back down, and then finish at the height of the platform after 30 minutes. And when I draw it that way, hopefully you notice that our starting point being here is off the midline, which tells us that this is a cosine function, right? Okay. All right, so let's identify, first of all, we know since this is cosine, our formula will be something like f of t equals a times cosine of capital B times t minus h plus k. We need to identify all of these different things. So a, the value for capital B, value for h, the value for k. Which the value for a, that would be how much we go above or below the midline, right? So how much we go up and down here or down here, which Comparing to our Ferris wheel over here, looks like it's going to be the length of a radius. So that'd be 67.5 meters. So that'll be our value for A. B, remember, comes from the period, and it's 2 pi over the period, and it looks like, again, it takes a full 30 minutes to do revolution, so our period will be 30 minutes. So we can find the value for B by doing 2 pi over 30, which reduces to pi over 15. H would be our horizontal shift, but notice in this case we're starting right on the vertical axis, so we actually haven't been shifted left or right at all. So our value for H would be 0. And then K would be where our midline is, which in this case we see is at 73.6 meters. Okay. So now we have all this information, we can fill it in up here. So we'll have f of t equals the value for A, which is 67.5 times cosine, the value for B, which is pi over 15. We do t minus h, but h is 0, so we have t minus 0, which just gives us t, and the value for k, which is 73.6. Okay. And that would be our equation. However, we're missing one thing here. Again, I'm going to go back to the starting point. Notice that it's below the midline, and cosine usually starts above the midline. So that tells us that this function has been vertically reflected, which means this should be a negative sign. So our function is now f of t equals negative 67.5 times cosine of pi over 15t plus 73.6. All right, so now we have that. We can use that to solve the problem we were given, which again was how long will a rider be at a height above 100 meters? And first of all, on my picture here, I'm going to draw where 100 meters, a height of 100 meters would be. Well, to be above the midline, so it looks like it'd be like somewhere up here, say 100. And if I intersect that with my graph, notice that there are 2 points where the height is exactly equal to 100 meters. And the time where it's above that would be all of this up here, right? So what does that tell us? Well, it tells us in order to solve this problem, what we first would probably want to do is know where are those 2 points where the rider is at 100 meters. So we have outputs of 100 meters there, which means we want to solve when 100 is equal to our function here. So the negative 67.5 times cosine of pi over 15t plus 73.6. Okay, and we can use a u substitution here because we have that pi over 15t on the inside. So we'll say u equals pi over 15t. So this would then make this 100 equals negative 67.5 times cosine of u plus 73.6. Go through and solve that. So we'll subtract 73.6 from both sides. Let's give us negative 67.5 cosine of u equals, over here we'll have 100 minus 73.6, which is 26.4. Okay, we can divide by negative 67.5. Okay, when we do that, then we'll have now cosine of u equals 26.4 over negative 67.5. And we went over to how to solve problems like this in section 6.4. So we'll use inverse trig functions, and I'm going to do this in radians again. So I'll do inverse cosine of 26.4 divided by negative 67.5. And that gives me U equals 1.9726. Okay, and then we'll have to recall from section 6.4 that that's one answer. And first of all, we note that we should have two, so that would be the first one. That answer's in the second quadrant. And since the cosine value we're doing the inverse of is negative, we should also have an answer in the third quadrant. So we can use that one in reference angles to find what that angle is in the third quadrant. Now I'm not going to go over that explicitly. You can look back at section 6.4 to recall how to do that. When we do that in this case, we end up with the other value for U being 4.3106. Recall these are our values for U. So we now need to use those to find our values for T. And so we'll use our U substitution, the fact that we have U equals pi over 15 times T. Yes, we'd have pi over 15 T equals 1.9726. Pi over 15 T equals 4.3106. Divide by pi over 15 on both of these. Okay. And when we do that, the two values for T that we get will be let's see, 9.4185. And from the second one, we get 20.5816. Okay, so we know from that the first time we get to 100 meter height is 9.4185 minutes. Second time is at 20.5816 minutes. Then we're coming back down. And going back to the question we're being asked to answer, it's how long are we at a height above that? Well, if we first hit it at 9.4 minutes and we get out at 20.5 minutes, how would we figure out how long that is? Right, we can just simply subtract the two. Okay. When we do that, we end up with 11.1631 minutes. So right around this Ferris wheel would be above that height for 11.1631 minutes. Okay. All right, that's it for now. Thank you for watching.